Hey guys, so in the last lecture we were discussing refrigeration and air conditioning. So in energy conservation management, that we were discussing some of the system utilities where we can save the energy. So in refrigeration and air conditioning, we have just studied vapor absorption system, and we have seen the difference between vapor compression system and vapor absorption system. So what is the difference between them? So now we'll see what are the factors that can affect the performance of the refrigeration and air conditioning systems. So we will see factors affecting R, A, and C. So factors affecting RSA. So we will start with this. So number one is design of heat exchangers. So process group has tendency to operate with high safety margins which directly affects the compressor suction pressure. For instance, a process having cooling requirement, suppose a process having a cooling requirement 15 degrees Celsius would need chilled water at a low temperature, but the range can vary from 6 degrees Celsius to 10 degrees Celsius. At 10 degrees Celsius, the chilled water temperature, the refrigerant side temperature has to be lower, say minus 5 degree Celsius to plus 5 degrees Celsius. The refrigerant temperature gain sets the corresponding suction pressure of refrigerant, which decides the inlet duty conditions for work of compression of the refrigerant compressor. Having the optimum minimum temperature difference can thus help to achieve highest possible suction pressure at the compressor, thereby leading to less energy requirement. A 1 degree rise in evaporator temperature can help almost 3% of power consumption. So 3% of power consumption can be obtained. Then the second system is maintenance of heat exchanger surfaces. So maintenance is also an important point, that after installation less power consuming heat exchanger, it is essential to have proper maintenance of the same. So heat exchanger can be improved by ensuring proper separation of oil lubricating oil and refrigerant, timely defrosting of coils, and increasing the velocity of the secondary coolant. So however, increased velocity results in larger pressure drops. So if you increase the velocity, it results in larger pressure drops in the distribution system and higher power consumption in pumps and fans. Therefore, careful analysis is required to determine the most effective and efficient option. Then third is multi-staging for efficiency. So multi-staging for efficiency. So efficient compression operation requires that the compression ratio be kept low. So compression ratio be kept low to reduce discharge pressure and temperature. To reduce discharge pressure and temperature. So for low temperature applications involving high compression ratio. So for low temperature operations requiring high compression ratios, and for wide temperature requirements it is preferable due to equipment design limitations, and often economical to employ multi-stage reciprocating machines or centrifugal screw compressors. Now, multi-staging are of two types, that is compound and cascade. compound and cascade, and are applicable to all type of compressors. So in multi-stage operation, the first stage compressor size to meet the cooling load. So first stage size to meet cooling load feeds into the suction of a second stage compressor after intercooling of the gas. So apart from the for second stage, here intercooling is done. So here intercooling is done. So a part of the high pressure liquid from the condenser is flashed and used for liquid subcooling. So the second compressor therefore has to meet the load of the evaporator and flash gas. So a single refrigerant is used in this system and work of compression is shared equally by the two compressors. Therefore, two compressors with low compression ratio can be in combination provide a high compression ratio. So this is the multi-staging for efficiency. And then fourth fourth point is matching capacity to system load. That is whatever the capacity is there to match with the load. So to part load operation, the evaporator temperature rises. The evaporator temperature rises and the condenser temperature. Evaporator temperature rises and the condenser temperature falls effectively, increasing the COP. But at the same time, deviation from the design operation point and the fact that mechanical losses from a greater portion of the total power negate the effect of improved COP, resulting in lower part load efficiency. Therefore, so efficiency is reduced. So, therefore, uh, so therefore, consideration of part load operation is important because most refrigeration applications have waiting load. Then fifth point is chilled water storage. Chilled water storage. So depending on nature of the load, it is economical to provide a chilled water storage facility with good cold insulation. Also, the storage facility can be fully filled to meet the process requirements so that chillers need not to be operated continuously. And an added benefit is that lower ambient temperature at night lowers the condensing temperature and thereby increases the COP. So this were the factors which can affect the performance of heating, ventilation and air conditioning. So now we'll see few of the energy saving opportunities, that is our crux of all the topics, that is how we can save the energy from all the equipments which we have discussed. So here now we are discussing RSC, that is refrigeration air conditioning. So how we can save the energy in RSC, so that we will see. So first is cold insulation. So that is cold insulation. So insulate all the cold lines vessels using economic insulation thickness to minimize heat gains and choose appropriate correct insulation. So by that means uh, we can save the energy. Then second, building envelope. So building envelope. So optimize air conditioning volumes by measures such as use of false ceiling and segregation of critical areas for air conditioning by air curtains. So that is the second point. Then third point is building heat loads minimization. So building heat loads minimization. So minimize the air conditioning loads by measures such as roof cooling, by measures such as roof cooling, roof painting, efficient lighting, pre-cooling of fresh air by air to air heat exchanger, variable volume air system, optimal thermostatic settings of temperature of air conditioned spaces, sun film applications, etc. Fourth is ensure regular maintenance of all the AC plants components as per manufacturer guidelines. Ensure adequate quantity of chilled water and cooling water flows over bypass flows by closing valves of idle equipment. Adopt adopt vapor absorption refrigeration system where economic permits as a non-CFC solution. Minimize process heat loads in terms of ton capacity as well as refrigeration level. Temperature required by way of flow optimization, heat transfer area, avoiding wastages and frequent cleaning. So these are the few of the points by which we can save the energy. Now we'll see the next system is ice bank system. So the next system is ice bank system. So the next system is ice bank system. So ice bank system is a simple technology. So it is a simple technology based on storing cooling capacity at night and using it following day to cool. So at night when the electricity is generated at a less cost, so chillers cool fluid is fluid and store it normally as a chilled water or ice. So during daytime when electricity is more expensive, the chiller is turned off and the stored cooling is used to meet the building cooling load requirements. So storage capacity is up to 15 kg of ice. The storage capacity is up to 15 kg of ice per unit. So at night, since the temperature is lower, it allows the refrigeration equipment to operate more efficiently than during the day, which reduces energy consumption. So in addition to that, less chiller capacity is required, which means lower initial capital equipment costs. Using off-peak electricity to store cooling energy reduces peak daytime power consumption, forestalling the need for additional expensive power plants. Now, what are the components that are used in ice blank system? So, frames are available in designs. So, frames are available in designs to meet your specific chilling requirements. All frames are custom made. This means dimensions can be changed according to your specifications. Water tanks are available for storage and recirculation of water. So water tanks are available. Uh, water tanks are available for storage and recirculation of water and are available in several designs. So tanks are made up of these tanks are made up of stainless steels with 50 to 80 of polyurethane insulation. So what are the applications? So applications are fresh produce. So applications are fresh produce, poultry processing, bakery, food and dairy processing, seafood processing, general food industry, beverages, concentrate coolings, and etc. So now the next topic is star labeled pumps. So we have seen ice blank system. Now, as you may have seen that in many equipments there are stars. Uh, stars are star rating is given. So it was given to show the efficiency of the particular equipment. So star labeled pumps. So in the schedule 7 of Bureau of Energy Efficiency specifies that the requirement for participating in the energy labeling scheme for pump sets covering electric monoset pumps, submersible pump sets, and open well submersible pump sets for labeling of the pump performance factor, which is relative of the pump efficiency with respect to BIS specified benchmark efficiency is measured. So after performing required test, energy labeling is given to the pump. So suppose it's 1 star and the performance of the pump set is between greater than 1 but less than 1.05. If it is 2 star, then it is greater than 1.05 but less than 1.10. If it is 3 star, so it is greater than 1.10 but less than 1.15, greater than equal to here. Okay, if it is 4, then it is greater than equal to 1.15 and less than 1.2. And if it is 5 stars, so it is greater than equal to 1.2. So this is the basic pump sets setting rating. So the rating plates details will be as per the requirements of the relevant English standards with all its latest amendments as per this. So this is the star labeled pumps. So now we will see. So in the next lecture we will see heat pump and its application. The heat pump and its application. So this is the last topic of this chapter. So just I'll revise the what are the equipments we have seen. So first we have seen boilers. Sorry. Then we have seen steam system. Then how we can save energy in steam system. Then we have seen uh, insulation. Then we have seen refractories. Then we have seen heat exchangers. Then we have seen in that pin classes. Then we have seen uh, heat recovery devices or heat recovery, and then we have seen cogeneration, and now we will see heat pump and its application. So these are all the equipments which we have seen one by one and how we can save the energy in that. So I hope this is the last topic of this chapter, this very big chapter. So it has very much weightage also in exam, and this will be the last topic. So I hope you have understood everything, and we will start this topic from the next lecture, heat pump and its application. So generally the difference between heat pump and the refrigeration the is the focus, that is what is the focus. So in refrigeration our focus is to remove heat, while in heat pump our focus is to add heat. So the main difference is the focus of the heat application. So I hope we will discuss this in the next lecture, and thank you very much.